Dad
Free
strength.
about to do this by himself. Free lessons from
V can beat us by himself.
Oh, V would definitely.
We can give you guys like a 600-pound weight limit and see.
It only take like 3 guys.
Yeah, then that'd be like a. You just pick the 3 strongest guys you guys
Up on
can
that
beat.
desk.
And then we'd be.
I
and then
think
we'd be
Kevin
close.
Hansen too. He's like freakishly strong. All right, or Chris
Let's
Hansen.
do it. Let's do it, boy.
All right. Here's what we're doing today. We're gonna go through a couple different things here today, where I want to talk about some new stuff, but kind of tie in with the homework that you have due, right? Because the homework that's due today is talking about domain and range. Obviously, we've been talking about that a lot, x's and y's. But then it talks about, is this a function or not? Those are kind of easy questions if you see the stuff we're going to talk about today. So you can go back and make a couple fixes. So here's the idea. First step. Let's go through a couple things we talked about yesterday. Something like this. Just something very straightforward and simple. Okay? All right. What I want to talk about is what is the domain of this graph, this function. Okay? Because it is a function. Now I'll explain how do I know that by just looking at it. But I want to know what's the domain, the x's. Now I want this in interval notation. So that was the stuff we talked about yesterday with brackets and parentheses. So now what does domain represent though? X's. Okay. So when we do interval notation, what is the lowest x number that I'm hitting? -6. 1, 2, 3, 4, 5, 6. Yep, I'll go with -6 now. Question. Bracket or parentheses?
Bracket.
Bracket. Why bracket?
Dot.
It's a full solid dot. No arrows, no open circles. So it is a bracket. What's the biggest x number? 2. Parentheses or bracket?
Bracket.
Bracket, because it's a solid dot. There, that's your domain. Easiest thing in the world. That's why I prefer interval notation. It's super quick to write for domain. Lowest number to biggest number. It looks like a coordinate, but it's not. It's representing lowest to largest number. Okay? All right, does that make sense? Domain. Now, here's the thing. What we talked about yesterday was, domain and range and x's and y's. But what you need to check for, if you want to know if this is a function or not, this is kind of the newer stuff that we're going to talk about today. Is this a function or not? I already said that yes, it is. Now, here's why. For every x number you choose, every x, I'm drawing little vertical lines to help you visualize this. Do you agree that there is one answer for each x you're picking?
Yes.
That's what makes a function. The best way I can explain a function to you is imagine you're typing a problem into your calculator and you hit equal sign, like a legitimate math problem. You just hit equals. What should the calculator do? Should output an answer, right? Should output one single answer, like a number, like a digit. Doesn't matter if it's a decimal, a fraction, positive or negative. I don't really care what the number is. It'll output something. That's a function, right? A calculator's like a function. It only displays one number. It shouldn't somehow just suddenly stop and say, I'm going to give you a different number today, at random. It should never do that. Because functions have to have one single solution. What would not be a function is something like this. So that is not a function.
Why not?
So is it then like impossible to make an equation that graphs that then?
No, you can make an equation that graphs it. The problem is it's not considered a function by definition standards. You can make a formula that would give you 2 possible solutions, just you would not be able to type it into a calculator. You'd have to learn how to graph things by hand. So there's a weird kind of way of doing it. That's what we're going to learn in this chapter. But what a function is, for every x you plug in there, should be one answer, right? Well, here's the problem. When I suddenly pick the number -3, this thing is spitting out 2 different answers. A calculator will never do that to you. So this problem, if you had it typed in the calculator, it'd probably give you like domain error. It thought you typed something in wrong, and it'll have you retype. No, don't get me wrong. There is functions that can double over themselves. We don't have a graphing calculator that can handle that, other than using like your Chromebook and going to like Desmos, like a more scientific based calculator, something that's a little more powerful. They can eventually attempt to graph these.
So what's it look like then?
Could be as simple as something like this. Now, instead of the x squared, the y is squared. So it doubles over itself on the y numbers. There's two y numbers. So that could be a simple problem that would represent that.
I regret asking.
Yeah, it's fine. That's something we're going to learn. It's not something that I expect to go, oh, that makes sense. Like, we haven't got there yet. All right, we'll get to that later. So that's a question for like a later chapter. Okay, we'll get to like, how do you know what the formula should look like? What are all the rules to it? That's like chapter 2 stuff. Okay, are we good with the idea of what a function is? And how I can look at it really quick and go, okay, nope, that's not a function. Yes, because it is literally called a vertical line test. If you can draw an imaginary vertical line and it hits twice, it's not a function. Now, how do you know if they just give you a bunch of coordinates? Right, because some of your homework, I think it was like, Haley, I think you walked in, you were asked about number 4 and 5, right? And I think on those, they give you stuff like this, correct? 3, -1, 7, 2, okay, it was giving you something like that, right? And they're saying this is the domain, let me get rid of that, there's extra comments in there I need. This is not a function. Why? What gives it away is right here. These two right there. I don't care about the other ones. These two gave it away. These are x numbers, correct? They're giving me 2 different y numbers. It's doing that thing. It's giving me 2 different y numbers for the same x number. That's not a function. I don't care if it suddenly did this. I don't care, like, that would be a function, because for every x there's 1 y number, but what gave it away was the 4. Applies to it receives. All right. Questions on yes or no, whether it's a function or not? Okay, now if you're doing domain on this problem, this is the question that was asked earlier. How do you know what the domain is? Domain are all x numbers. You just list these off. So it'd be 3s, 4s, and 7s. Even though it's not a function, you still can list them. Okay, range would be the other numbers. You put them least to greatest. Okay, are we good with all the kind of the weird stuff in the last couple of days? That makes sense somewhat? Okay, now, let's go back to the problem I had up here on the board earlier. Going back, it was something like, I don't know what it was. It was something like this.
And then it was positive.
Something like that. I don't know, something like that, right? Close.
They're on the same level though.
Yeah, oh, they're on the same level?
Yes,
All right, same level. There you go.
There you go.
Okay, so something like that. All right, so we talked about domain was from -6 up to 2. 1, 2, 3, 4, 5, 6. Yeah, okay, so -6 up to 2. Now, the second question was, what's the range? The range. So that's y numbers, right? What's my lowest y number on this graph? 1, okay? So the lowest y number was 1. Bracket or parenthesis? Bracket, because they're actually solid dots. Okay? What's my highest y number?
2.
Well, highest y number? 1, 2, 3, what?
3.5.
3.5-ish? 3.5?
3.6.
3.6? Okay, let's go
Yes.
3.6, and we're going to put a bracket there. Why I put a bracket? It's literally a solid dot. Like, there's no open circle up there. It was a solid dot, so I'm just going to say 3.6. Does that make sense, the idea of what range is? Okay, lowest
I
to
think it's
biggest number,
3.6.
and you're using y numbers, so you gotta get used to the y numbers. Okay, questions at all?
No questions.
Okay, so these are pretty straightforward, right? It's trying to get you used to like what domain and range is, trying to teach you the easiest way to write it. One of the things that I want to discuss today, like the new stuff that I want to get to, because this is kind of mixing old with new. The new stuff I want to talk about today is number 1, how does this work? Again, I think we did one of these at the very end of the class yesterday. How does it work if you have multiple breaks in the graph? How does it look if we're going to talk about increasing and decreasing functions? That's something that's different, right? This problem, if I was to ask you whether it increases or decreases, that's a very weird question because it does both, if you see that. As I go from left side to right side of this graph, do you agree that it kind of climbed for a little while and then it suddenly started going down for a while? So it actually had a moment where it increased and decreased. Like it has both in one graph. That's normal, right? When you're looking at data can go up and down depending on the day, sales, whatnot. Well, if I was asking for increasing and decreasing, you'd have to give me the intervals where it happens. So that's the tricky part. It's mixing this idea of domain and range, because they would like you to answer the question by describing where does it increase, where does it decrease. If they're shared, like this one, it's literally like, at one point it just turns directions, right? That's the tricky part. That's probably the most difficult thing to teach to somebody, is to describe where is it increasing, where is it decreasing, and how do you know. So, increasing functions. As you go from the left side to the right side, left to right, where is it going up? Okay, so when I ask this question, I am looking for x's. I'm basically asking, where does the domain increase? So I'm looking for x's. So you're looking at kind of the graph. You're looking at, it's climbing. Do you agree that it climbed from basically here up to basically this point?
Yes.
It was like going up.
A little bit to the right.
Okay, a little more to the right.
Yeah.
Okay, let's say about right here.
Yeah.
Okay, let's say there. Okay, in that moment, in that little band, it was climbing. So I want the x numbers, I want the interval. What was my lowest x number? -6. And I'm using a bracket, because it was a solid dot there. It climbed all the way up until about 1, about right here. Let's say it was climbing up until about -1 on the x-axis. Now, here's the weird thing. This is the goofy part. I'm going to put a parenthesis, not a bracket.
Why?
Okay, there's the question, right? Why would you do that? Because if you look at the graph, you're like, "Whoa, that's a solid dot." Because at that moment, do you agree that it suddenly switched directions? Where it switches, that inflection point, when it goes from like increasing to decreasing, where it suddenly changes, that's not considered to be either increasing or decreasing. It's shared between both. This number will literally be shared between the increasing side and the decreasing side. So you have to split it to both to use a parenthesis. It's not considered to be one or the other strictly.
I don't like that.
Yeah, I know. It's because everything else I've taught you up to this point has been like, okay, solid, use a bracket. It's an open circle, use a parenthesis. But when you're talking about increasing and decreasing, and if they share a number, it's automatically a parenthesis. That's the hard part. Now we're starting to get into that weird gray territory where we're starting to mix the rules together.
I need you to explain that again.
Okay, let's go to decreasing. I'll do it one more time. So let's go to decreasing. Do you agree at one point in this graph this thing was going down?
Yes.
Okay, we can see that. Again, I want to use x's. We're using the domain to help us with our answer. Okay, so we start at the lowest spot where it started going down. What was my lowest spot? -1. And it went up until about what, 2?
Yeah.
Okay, so those are my numbers. Now, do you agree that this moment was shared between increase and decrease?
Yeah.
You can't use a bracket there.
Put a parenthesis.
You
on
have to
the
put a
negative one
parenthesis,
side.
yep, put a parenthesis on the -1, and use a bracket at 2 because it ended at 2. The parentheses used if it's shared. That's how it's used. I know it's a solid dot there. That's the confusing part. It's a solid dot at -1. But since it's shared between increase and decrease, you can't consider it to be in one versus the other. So you have to just like put a parenthesis there. Questions? I know it's tough. That's like the newest part we had to introduce today. And I wanted to save it for today because I did not want to confuse people yesterday. Because everyone kind of had an idea of it. Some people could really rattle off those numbers really quick. Now we're getting to that weird muddy territory. Okay, are we good so far? Okay, let's do one more. Let's not go increase and decrease. Let's just talk about domain and range so we can go to brackets and parentheses, the old school rule. But I want to do one where we have multiple breaks in the graph. I only got 2 problems left today. This is it. Okay, 2 problems left and then we're done.
Pass her out.
Okay. So no increase, no decrease. Get rid of the whole idea of parentheses and brackets. Just get that out of your head. Okay. Let me give you a graph. Let's say we're doing something like this. Let's go here. And let's go here. And over here. Okay, we got lots of things going on here. I only got 2 problems left. I got this one and the next one. Okay. Again, I know this is really tough to write down, to look at. Okay, so here's the question. I want to know domain only, not increase, decrease. I don't care about that because it's kind of going all over the place. I want to know just where the domain is. So domain are just x numbers, correct? Okay, so domain. Now we have multiple breaks in the graph. So this is not a continuous function. It's kind of piecewise. There's a bunch of different pieces. You know, you took breaks. Maybe it was like your business model. You know, you had a business, you took a vacation, you had you were selling some products, you took another vacation, you had to buy some supplies, you took a vacation, you started selling again, or you went to.
Seems to me like you better quit going on vacation.
Yeah. So, but the idea is maybe it was production. Maybe you're changing up the production line, so you had to stop for a little while in production. Maybe this represents manufacturing numbers. So after a while, you change the manufacturing line, you decrease the numbers because it wasn't working out. You're losing a lot of product. The manufacturing process doesn't work. You know, it can represent anything. Okay, so here's the idea. What is my lowest x number that I have? Negative infinity, right? This is an arrow. I can pick any x's this direction. So my lowest number is negative infinity. Notice, I use a parenthesis for infinity. It's not an actual number, it's a direction. Now, it went up to this number right here. What is that number?
Six.
Negative 9. That number is a negative 9. Now, how I know that? My graphs go up to 12. 11, 10, 9. So it went out to negative 9. Now, is that a parenthesis or a bracket? Bracket. Okay, this is old school rules, parentheses and brackets.
-9.
Yes.
-9.
Council, do we have to do anything for like,
For lunch, yeah, I think I sent a text earlier today to everyone if like you're taking numbers.
okay.
So if you didn't get a text, you're good. All right, so up to negative 9, does that make sense? Question.
Do we have to do anything for the egg cookout or no?
I already have the proposal. So, okay, so up to negative 9. Now, since there's a break in the graph, what we do is we do a union. A union is where you're going to add the next set. It's not an intersection where you're looking for overlap. I'm looking at, can I add another chunk to it? Seriously.
Wait, why is one side a parenthesis and the
It's kind
other
of
a
impressive you heard that word.
Doesn't matter.
Isn't that impressive?
Wait, what do it mean?
Yeah,
what?
You want to see it?
Yeah, shut up.
Yeah.
Actually, go ahead.
It wasn't very loud.
I'm gonna. Yeah.
Think of
Look
that.
at that mermaid. I'm gonna die from this.
What is taco?
Maybe I go
Depends
for
what time you
my
get taco.
Yes, it's a taco.
Oh, I thought it was just a good taco.
Should I show the camera?
I got
Yeah,
like
you should
3.
show the camera and go.
Oh, hamburger. Maybe. I'll think about it.
Now it's not that
I
ball.
might be getting to do that.
You
said what?
Oh, dear judge, trying to take over.
I won't need to.
I didn't try it, but
I'll
you did. Almost
go
every
to
drop.
dinner.
Cheese
Or like a.
Yes.
Perfect. Okay, sorry. Homecoming stuff, always adding up. All right, so we went from negative infinity up to 9. Now, we stopped. There was a break in the graph. And now we picked up here, this is what, negative 7? Does it need a bracket or a parenthesis? Bracket. So bracket, negative 7. The reason why, it's a closed circle. Now, we worked our way up until, what, negative 2?
Yes.
Parenthesis or bracket?
Parentheses.
Parenthesis, because it's an open circle, right?
2.1.
Then we do another union. Now I'm going to carry on to the next line so I'm not spilling over. So another union, that would be normally here.
Bracket.
Bracket, and what is that x number?
0.
0, and it's a bracket because it is a closed circle up to
2. Bracket.
and bracket again. Because brackets are for closed circles. We do another union.
Parentheses.
Parenthesis.
4,
What is that? 4.
comma, infinity, positive.
Yep. Pos infinity. Parenthesis.
Parentheses.
There's your domain.
Square.
Okay. Now, if I was doing a range, range now. This is my last problem of the day. Last one. The second one. Range. Range now. This is y numbers. Same exact idea. What is my lowest y number that we have?
Negative 4.
Negative 4? Okay. Negative 4 now. Bracket or parenthesis?
Bracket.
Bracket, okay? Because that is a closed circle down there. That is the lowest. Now, we go up to
Negative 2.
negative 2. Bracket or parentheses?
Bracket.
Bracket.
Oh.
Union again, because there's a break in the graph. There's a break in the graph. Now,
-1.
okay, good. -1, because this is my next y number. Because again, let me get rid of all these lines here.
Bracket.
So, we're starting at -1 and we're going up to this point. Now, why I'm going to stop there, because there's an open circle there, like straight across. So I'm going to have an open circle. So I'm going to go from -1 with a bracket up to, what is that number? 2, and have a parenthesis.
And parentheses too.
Then we do another union, that would be normally right here. We do another parenthesis where we're picking up at 2 again, because that was an open circle, so I cannot include 2. So I stop at 2, and I picked up right after the number 2. I know that's really goofy. And then I go up to positive infinity. Parenthesis. Yes?
You not do anything with that other line?
No, because that was kind of like this line, it's horizontal, it's supposed to be flat. It's already in the middle here, so those numbers are already accounted for.
If there was like a small, like little angled one, and
Oh.
it's in the middle.
Yeah, so if there's a small angle line that's going up, you would go from like here and you just go up forever.
If it went by, so if it went up by 1.
And then like close.
So yeah, so if this line suddenly did this, now I would start at -1 and go to positive infinity. Because this thing will overlap over those, so we took care of everything.
Okay,
Now what if it had a closed circle on it?
This had a closed circle.
That one, like 1 by 1.
Okay, so right there, and it had a closed circle at this spot right here.
No, like the line that with the blue arrow is just a 1 by 1. Like
It
top
went up
left,
by
bottom
1?
right. Closer.
Right here.
No.
Come here. Sorry, I can't tell what you're saying.
Here, let me make
You're
sure.
trying to explain left, right, and up, down.
Make sure he's doing what I'm doing, or what I'm thinking.
Okay.
How would Ward know what you're thinking if he can't?
Okay, so, all right, so both closed circles, diagonal, I don't care which way you went. Okay, so do we see that 2 is closed circle?
Yeah.
This closed circle covers these two. Because we actually have a number at 2 that this one works. So I would still go, I would start at -1, right? So the only difference would be, okay, so the range would go from -4 to 2, -2, sorry. And then we do union, we pick up at -1, right? That's this number right here. And going up, now I have all the numbers covered going up, because this number covers those, and it goes up forever. So I'd go from -1 up to positive infinity.
So don't have any intersections.
There wouldn't be, the only intersection is between these two, which is the gap right here. Because we don't have any more gaps after -1, because everything's covered.
Okay.
Because this literally filled the gaps, so I can just continue the whole way across.
I don't like that.
I know.
Can I see the marker real quick? I don't know how to explain it. Try to show
Go
you.
there.
Alright, so what if it went like this? What if it were like...
Still, it would still be the same answer. It'd be this answer again.
This answer?
Because 2 happens to be covered in the middle of that line, and so it would fill the gaps with the other 2.
So if 2 wasn't covered, but it was in the middle of the line, is it you just cancel it out?
Like that? If it wasn't covered?
Let's not do that.
Okay.
Ever.
What the heck?
Like if it was just so there's a line, right? And there's another line that's within that line, but like
It stops.
graph.
Here
What are you even talking about?
No, this is good. We gotta figure out all these weird little intricacies.
Okay. So if
Okay.
it was like right here, and we went to like right here,
Yeah,
and there's a line. So
Yep.
it's like within this line.
it's still covered.
You don't do anything.
You
with
don't
it?
have to do anything.
Okay.
You only have to do, what I'm always looking at is just what are my y numbers. I don't really care if lines are inside other lines. I'm just looking like bottom up.
How is that inside
Okay.
another line?
Because I'm looking at range, right? I'm
The
just looking at
Ys.
like the y numbers.
I'm-
So like
yeah.
the y numbers are already covered like between here. So
got it.
they're like kind of overlapping.
So I wasn't sure if it was like 3 right.
Yeah.
All right, hey, these are good things to figure out. Like, we have a lot of stuff to talk about with this stuff, and it's nice to see different examples. I'm gonna stop there today. We've done enough. You have the rest of the time today. You can kind of relax. I know we have homework due today. You can work on it. You can ask questions. That's for page 143, 159. I don't know if I see you guys necessarily tomorrow. I'm gonna have to look at the schedule. If I do, it's only for like 20 minutes. If I even see you at all, I don't think I do though.
I don't know.
So.
Yeah, I gotta move on like one of
Will
the
I?
crap tabs you got.
Okay.